So I will explain. This is about the crypto lab networking and the computer security. Of course, first of all, I started in the function lab or lab task symmetric. I used this website and opened it, this website. And when I open it, I found this space where I passed this text, which I had it and they give it to me here in the assignment. They give it to me this text and I copy it from here to the website. After that, I select the crypto graphics and I run it. That's crypto. And here also I selected the cipher identifier. Uh, After that, in the step 4, I pressed the button analyze to analyze the cipher Vigenère or Vigenère cipher. So when I did that, I had this, of course, I put this radio bottom unknown only the blank text, which I have it from the assignment because I had only the blank text from the assignment. So I found they give it to me in the left-hand side of the screen or in the right, that's left side. I had a lot of cipher text or plain text. They translated and I passed here also some of it. So that's you can see a lot, and of course I didn't put all. I put only some of this cipher text, which I get it. But in the end, I have this cipher text, which is clear. Even I put it here in the general also. Uh, so after that, there are I find how I found the bigram and diagram. First of all, I selected the bigram from the website like this. What I did the circle here, and that's the bigram mean is there is two sequence of letters. How to convert this, and even they give it to me here. This in the left side, the result about this. It was the percentage and how the letters, the mean two letters for how many percentage they use it in this text and so on. And in the diagram also, like that, I did, and I chose the diagram. And also I did, I press the key compute, and I found this, and that's the diagram. That means they used three letters to convert this ciphertext. And also I found the same, and they give it to me the percentage and so on. I learned from this the cover text, cipher text. We can use two kinds of the methods, which bigram and diagram. So there is the code which we can use it, of course, in manually, and also I tried to use it, but it was a little bit too little time and so on. Of course, by the if I use the terminal in the Linux, I can use this code, for example, tr, and I will use efn to convert to YRT, and also it will send it to this file in file .txt2 and the out file .txt2, the extension file. So in 5.2, I use the OpenSSL commands line, and here they give me that's this of course I preparation and this, and I use this command to create the files. I this commands and I got this file. Even when I open the file, I can use it and I can see the data, what I did it or what I wrote there, because and I generate the random keys. I have two key, the normal key, and I have IV keys, and I open open SSL to generate the random keys. That's we're using the open random slash hex 16 and that's I open brackets and I key dot txt, and I got the key from generated from the systems. And also I use another commands to get IVS commands, and also I use this and I run it in the terminal and I found this key. After that, I use the two example. The example when I use block cipher AES E128 and CBC encrypted the files. I use these commands to encrypt these files. After that, also I decrypted the file by using these commands, and I found they give it to me this decrypt because I use here the different CD, and in the another one I used E. So this is the difference between encrypt and decrypt commands. And even I bought the screenshots for this shots. I put it here about that. In example 2, I use the block cipher ES256 CFB, and I use the commands the same, almost the same, but there is I use the cipher is 120 25 or 256, and there is I put 128, and this is, and also I encrypted the file like that, like previous, and I use the command. Even here I use the E for the encrypted, and here I use D for decrypted the commands in this. And also the example or third example, I use the stream cipher RC4. So that's I use 3 examples, sorry, not 2. And RC4, I encrypted the file like that. I created the command, the new command, and also I use the command to encrypt this, and I grenade this to open the key. Of course, I had the key here. I use the key, and after that, I use this encrypted this commands, and also decrypted this command to get the answer of this encrypt, and I had the decrypt. My observation about this examples, of course, the significance of the IV in CBC mode, of course, it is, and also the symbols of RC4. That's the IV. It is for, of course, and CBC is more significance, and also the importance of the security, meaning the keys and IV. So that's if I have the keys and IVS, that means I can have more powerful and it will be more important. The task 3, the mode of the CBC Vs, so ECB and CBC. So in encrypted, I used ESE 120 ESB. I encrypted the files like this, and I open this. Random key here, and I did encrypted for the image, which I have it this original .bmb, and I use this command first of all. And the second, I extract the header of this image for the first 54 bytes. After that, I extracted this by using this commands, and extracted that's also after that I encrypted body of this command by tile minus C minus C plus 55, and I send it to bct.bin body. After that, I extract this body. So combine the original header and encrypted body. I use the commands and so on. And in the end, I got like this, the image. But in step 2, I use encrypted using the CBC, and I use there are a lot of commands, which is also it give me some like this commands to have the key, and also I open the ENC, and I got this is another file. I did the encrypt BMB file, and I use this command. And the third, I extract the header, of course, and I use this command to extract the header. And in the end, I have this picture. And I encrypted the body tile by using the dial minus C plus 1 to encrypted .bin CBC body. Combine the original header to encrypted body. I utilize the commands. That's this is the CBC body, and last encrypted it was CBC.bmb to get the combined original header to encrypted body. And this is in the end image. Of course, you cannot read anything, but like when I compare it between if I compare ECB with the CBC, that means is the CBC is more powerful and it is more strongest. So that's of course I can get from this a lot of information, and that is very important. And in the end, I use the RCK by the Sagi, and this is the Sagi, and I bought this Python code, and I found it, and it give me this is the private key, and I use the reference. So I use the Sagi here, and like that's I found a lot of information. Thank you. Bye bye. I am Ishaq Al Amri from Global Colleague.